This is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. In this lecture, we'll discuss some problems on transistor hybrid parameter model. That is, we are mainly concentrating on transistor amplifier, that is common collector transistor amplifier. So we'll be solving some problems on common collector amplifier, and we'll be doing the analysis using hybrid parameter model or else H parameter model. That means we are going to calculate the input impedance, our voltage gain, output admittance or output impedance, and overall voltage gain, overall current gain, and power gain of a common collector amplifier using H parameter model. That means we are going to replace the transistor connected in common collector configuration using hybrid parameter model, and we'll be finding the parameters like voltage gain, current gain, input impedance, output impedance, and overall voltage gain, overall current gain, and the power gain. So as we all know that whenever we are doing the AC analysis, that is calculating all these characteristic parameters, is known as AC analysis of a transistor circuit. So whenever we are doing the AC analysis of a transistor circuit, we need to follow some procedure. What is that procedure? So first of all, draw the transistor circuit as usual. That is, draw the actual circuit diagram of the transistor. And then the second step is replace the coupling capacitors and emitter bypass capacitors, if any are there, with the short circuit. And the third step is short circuit the DC supply voltages or else connect the DC sources to the ground. And the next point is identify the terminals of the transistor, that is emitter, base, and collector in the circuit diagram, and also locate them and locate these points in the equivalent circuit. And finally, we need to replace the transistor by its H parameter model. So these are the steps to be followed whenever we are doing AC analysis for any transistor circuit. Now, before that, we'll have some discussion on the formulae that are related to the common emitter or common base. These are applicable for all the configurations as I told you. So the current gain formula is minus HF by 1 plus HO into RL. Whereas, so here these are the formulas given for H common emitter. So we can also apply these formulas by just replacing the H parameters of common collector configuration, that is minus HFC by 1 plus HOC into RL. And similarly, current input resistance RA is equals to HI plus HR into AI into RL. This is the input resistance, and another formula, by replacing this HAI formula in this, we can get this one. And voltage gain is calculated as AV is equals to AI into RL by RA, where RL is a load resistance and RA is the input resistance, which we have calculated from this formula. Next, output resistance. The formula for output resistance is given by RS plus HI divided by RS HOE plus delta H, where delta H is given by HIE HOE minus HR HF. So, and one more problem is there, one more formula is there for calculating this R naught, which is equals to reciprocal of Y naught, where Y naught is given by HOC, or as we are discussing about common collector, HOC minus HFC into HRC divided by HIC plus RS. So this is another formula. So we can either use this or use this. So we can find out Y naught, and once Y naught is obtained, the inverse of Y naught is nothing but R naught, that is output resistance. These are the basic formula. And here, now the values of H parameters, the typical values of H parameters that we need to remember. Whenever you are solving the problems, if the H parameter values are not given, you can use these typical values of H parameter. That is, we can consider these as ideal values. So for all the three configuration, these are the values of various H parameters. So HI, HR, HF, HO, and for common emitter configuration, these are the values for H parameters. That is, HI value is, HIE is 1100 ohms, 2.5 into 10 to the power of minus 4. This is the HR value. So like that, we have various H parameter values for all the three configurations. So if the H parameters are not given, you can use this typical values. Now coming to the conversion formula. So here I am discussing only the conversion formula. If the H parameters are given in terms of common emitter, if I want to analyze common collector amplifier, before that, first of all, I should convert the H parameters of common emitter configuration into common collector. So for that, we have the conversion formulae. So these are the conversion formulae in order to convert common emitter H parameters into common collector H parameters. So these are the formulas that we need to remember here. So HIC is equals to HIE and HRC is equals to 1 minus HRE, where we already know that HRE value, typical value of HRE is 2.5 into 10 to the power of minus 4. This is the HRE value. Just now we have seen 2.5 into 10 to the power of minus 4. So 10 to the power of minus 4 means 0.0002. That means it is very much less than 1. It is very much less than 1. So if I compare these two, so HRC I can write it as directly H1 because HRE is very much less than 1 because it is 2.5 into 10 to the power of minus 4. And HFC value is given by minus of 1 plus HFE and HOC is equals to HOE. See, these are the conversion formula that we need to remember. Now let us discuss some problems on common collector configuration and how to analyze the various characteristic parameters of this common collector amplifier. Now, the first problem, a common collector circuit has the following components. R1 is equals to 27 kilo ohms, R2 is equals to 27 kilo ohms, RE is equals to 5.6 kilo ohms, and RL is 47 kilo ohms. RS value is 600 ohms, and the transistor H parameters are HIE 1 kilo ohm, HFE 85, HOE 2 micro ampere per volt, and HRE is not given, and determine AI, RI, AV, R0, and you can also calculate, you can add two more AVS and AIS. Calculate these also. So calculate all these parameters AI, RI, AV, R0, that is input voltage gain, input impedance, current gain, input impedance, voltage gain, output impedance, overall voltage gain, overall current gain. So these are the parameters that we need to calculate. So before that, first we need to draw the circuit diagram. Then we need to draw its equivalent circuit, and then we have to go for the H parameter analysis. So here, now first of all, it is a common collector circuit. Common collector means collector is a common terminal where the base acts as the input and the emitter acts as the output. And we do have R1, R2. This is R1, this is R2, which are connected to base. Okay. And then we have emitter resistance also, which is connected to the emitter terminal. And we do have here, let us consider we have a capacitor and we have a load resistor RL, and across which we are calculating the output voltage. So as it is a common collector configuration, collector is common between the input and output, whereas the input is applied to base terminal. So this is the circuit diagram. Okay. So now this is RS plus minus PS. So this is a C1 and this is C2. So this is the common collector amplifier circuit where we have R1, R2, RE which is connected to the emitter terminal, and this is also grounded, and the output is taken between collector and the ground, where the collector is a common terminal which acts as a common between the input and output. The input is applied to the base and output is taken from the emitter. So this is the common collector configuration. So now what we need to do, we need to draw the equivalent circuit. So how to draw the equivalent circuit? Before that, just follow the procedure. So if any capacitors are there, just short circuit the capacitors and connect all the DC sources to the ground. So here only we have VCC. This should be connected to the ground. Okay. So now here the equivalent circuit will be, so we have RS and we have voltage source, that is plus minus Vs, and if it is connected to ground, so now R1 will be connected in between base and the ground. So that means already R2 is connected in between base and ground. This is R2, and R1 will now be connected between base and ground because we have short circuited the AC supply. So now we have input at the input side, the transistor equivalent circuit. So, and the transistor should be replaced with its equivalent circuit, that is HIC we have. This is plus minus, and this is HRC into output voltage. What is the output voltage? We are taking it from the emitter terminal. So that is VE, HRC into VE, whereas this is the base terminal and the current flowing is IB, and the voltage across this one is VB. Okay, and now coming to the output side, we have a current generator whose magnitude is given by HFC into input current. What is the input current? IB, and we have HOC. This is our, and then the current flowing is IC, and here we do have RE, and also we have RL. Okay. And here from the RE, if I short circuit this, then what about these two resistors? These two will be connected in parallel. So these two are the parallel connection. So IL, and across which we are measuring the output, and this output is nothing but V0 is equals to VE. This is the collector terminal, and the current flowing is IC. Okay. So sorry, not collector terminal, it is emitter, IE. Whereas this is the collector terminal. So the collector terminal is grounded, right? So this one. So base, emitter, collector. Whereas the collector is common, which is grounded. So this is the equivalent circuit. Now, I hope it is clear. Now the first thing, AI. Now the first thing, AI, that we are going to calculate, that is current gain. Already we know the formula. What is the formula for current gain? AI is equals to, so minus HFC divided by 1 plus HOC into RL dash. So why we are taking RL dash? Because at the output side we have two resistors connected in parallel. So RL dash is nothing but RE in parallel with RL. Okay. So before that, first of all the H parameters given in common emitter configuration. Now I want to convert them into common collector configuration. So HIC is equals to HIE, where HIE value is given, that is 1 kilo ohm. Okay. Next up, HRC is equals to 1, which we have seen already. Next formula we have seen, and HFC is equals to minus of 1 plus HFE. What is the value of HFE? Minus of 1 plus HFE value is given as 85. So 85. So it is minus 86. Okay. And then HOC is equals to HOE, where the HOE value is given, that is 2 microampere per volt. Actually it is 25 microampere per volt. Just it is a mistake. So HOE value is 25. microamperes per volt. That means as a typical value is 25, it should not be very much less than 25. So actually it is 25 microamperes. It is a printing mistake. So typing mistake. Okay. So this is HOC is equals to HOE, which is given by 25 microamperes per volt. Right. So now I want to calculate the current gain. So before that, I want to find out RL dash. What is the value of RL? RL value is 47K in parallel with 5.6K. So how can we calculate this value? 5.6 into 47 into 10 to the power of 6 divided by 5.6 plus 47 into 10 to the power of 3. So this is the value, this is the way we can calculate the parallel combination. So here now RL dash can be given, by, so RL dash value is 5 kilo ohms. So if you evaluate this value using the calculator, you'll get the value of RL dash as 5 kilo ohms. Now I can calculate AI by substituting 5 kilo ohms, that is RL dash value. So AI is equals to minus HFC. What is the value of HFC? Minus of minus 86, because already in the formula we have a minus. Then 1 plus HOC. What is the value of HOC? 25 into 10 to the power of minus 6 into 5 into 10 to the power of 3. So this is the value of this is the substitution of AI value here. So if I calculate this one, I'll be getting this value as 76.44. So this is the value of, this is RL dash we have calculated, and this is the current gain, which is 76.44. Now the next parameter is, that is RI. The formula for RI is HIC plus HRC into AI into RL dash. Wherever we have RL, we need to place RL dash, because at the output side we have two resistors connected in parallel. So that is why HIC value, that is 1000, because it is 1 kilo ohm. So HRC value is 1, and AI value is 76.44. 76.44 into RL dash is 5 into 10 to the power of 3. If I evaluate this RI value will be now equal to 383.2 kilo ohms. So this is the value of RI. So here that means the input impedance of a common collector amplifier is very high. Okay, the input impedance of common collector amplifier is very high. That point we can identify here. Next thing, the next thing is we are going to calculate voltage gain. Voltage gain is represented with AV, which is given by AI into RL dash divided by RI. Right? So AI, what is the value of AI? We have got 76.44 into RL dash. RL dash value is 5 kilo ohm, that is 5 into 10 to the power of 3. And RI value just now we have calculated 383.2 into 10 to the power of 3, that is kilo ohm. So if I evaluate this one, I'll get the value of voltage gain as 0.997. So this is the value of voltage gain. So where we know that the voltage gain of common collector amplifier is almost unity, and that is why we always use this, call this common collector configuration, or else common collector amplifier as emitter follower, because here base is the input terminal and emitter is the output terminal. So what do you mean by this is the value 0.997? That means it is approximately equals to 1, right? So here what does it mean? So here voltage gain, basically it is defined as a ratio of V naught by Vi is almost equal to 1. So V naught is equals to Vi. That means the output voltage is following the input voltage. Where, how can I say that the output voltage is following the input voltage? Because V naught is approximately equals to Vi. So that is why it is called as emitter follower, and we can use this common collector amplifier as a voltage buffer. That means it just stores the voltage and it will be given as the output. So that is the major reason why we are calling this as common collector amplifier as voltage follower or emitter follower or voltage buffer. Okay, so now coming to the next thing, that is R naught. So before calculating R naught, we are going to calculate Ri dash. If you look at this circuit diagram, so the parallel combination of this one is Rb. Okay, R1 and R2 is considered as Rb, and the input impedance that we can see from the input terminal, look into the input terminal, is Ri. So the parallel combination of Rb and Ri will be overall input impedance. So now what I am going to calculate, overall input impedance. So here overall input impedance or else input resistance Ri dash. Okay, Ri dash. So Ri dash can be calculated as Rb in parallel with Ri. What is Rb? Rb is nothing but R1 in parallel with R2. So what is R1 value? R1 value in the formula is given as 27 and R2 is also 27. So 27K in parallel with 27K. If you calculate this one, that is 27 into 27 divided by 27 plus 27, you will get the Rb value as 13.5 kilo ohms. This is the Rb value. So now from this, I am going to calculate Ri dash. So what is Ri dash? 13.5K in parallel with Ri. What is the Ri value we have got it? That is 383.2K. If you evaluate this one, so what you'll get? I will get Ri dash value, where Ri dash value will be 13.04 kilo ohms. So this is the value of overall input impedance by considering. So this is voltage gain, overall input resistance, and this is a value of overall input resistance 0.04, whereas the Rb value is given by 13.5 and the Ri dash is given by 13.04 kilo ohms. Now coming to the next one, so that is R naught, output impedance or else output resistance. Output impedance, which is R naught. So here, how to calculate R naught? So R naught is equals to 1 divided by Y naught. What is the formula for Y naught? HOC minus HFC into HRC divided by HIC plus RS dash. HIC plus RS dash. What is RS dash? RS dash is nothing. RS dash is nothing but here when you look at this equivalent circuit. So if you consider RS and R1, R2, so RS dash is given by RS in parallel with R1, R2. Okay, so RS dash, those are also considered to be input resistance. So RS dash is equals to RS in parallel with RB, where RB value is 13.5, whereas the input resistance in the formula, it is given as 600 ohms. RS is given as 600 ohms. 600 ohms in parallel with 13.5 into 10 to the power of 3. If you calculate this RS dash, you will get the RS dash value as it is 574 ohms. It is 574 ohms. 574 ohms. So here, this is the value of RS dash. Now substitute this in this R naught. So R naught is equals to 1 by HOC value, you know, that is HOC value is what? That is 25 into 10 to the power of minus 6, 10 to the power of minus 6 minus HRC value is 1, HFC is minus, just a second. HFC is minus 86 into HRC is 1 divided by HIC value is 1000 plus RS dash value is 574. So if you calculate this R naught value, we'll get the value of R naught as it will be output resistance will be very less. So R naught value is 18.31 ohms. This is the R naught value. So here we already know the characteristics of common collector amplifier, that is input impedance is very high and output impedance is very low. So this is the R naught value. And here if you look at the equivalent circuit, so the output impedance is nothing but the impedance that we can see when we are looking into the output port, and this is nothing but R naught dash, where R naught dash is when we are considering the RL also into effect. So here the overall output impedance, that is R naught dash, can be calculated as R naught in parallel with RL dash, where we already know the value of RL dash. What is the value of RL dash? 5 kilo ohms. So just substitute 18.31 into 10 to the power of 3 in parallel with this RL dash value is 5 kilo ohms. So 5 into 10 to the power of 3. So if you calculate this value, you will be getting this R naught dash as 18.24 ohms. This is the value of output impedance. That means even the overall output impedance is also less. So now this is about the voltage gain, current gain, output impedance and the overall output impedance. Now let us see the overall voltage gain. So how can we calculate the overall voltage gain? By considering the source resistance into effect. So overall voltage gain, which is represented with AVS. So here how to calculate this AVS? So AVS is nothing but V0 by Vs. So where V0 is given by VE by Vs, and I am multiplying and dividing this one by VB. Okay, so then what we can do? VE by VB into VB by Vs. VB by Vs. So this is the formula for overall voltage gain. So VE by VB into VB by Vs, where VE by VB is nothing but without considering the voltage source into effect. So here I can write it as AV into VB by Vs. So now for doing this, for calculating this AVB by Vs, we need to take the Thevenin's equivalent circuit of input voltage, input source. So that is here Vs, okay, plus minus Vs, and here it is RS, and here we have overall input impedance with is RI dash, and here if you look at this equivalent circuit, all these resistors are connected in parallel, and hence we can say that the resistor voltage drop across the resistances is same because these are all connected in parallel. So this is base and this is collector. So now I want to calculate VB. So how can, by applying the potential divider principle, VB can be calculated as the input voltage into the that resistance, that is RI dash divided by RI dash total resistance RI dash plus RS. So what is the value of RI dash? We have got RI dash value, we have got it as 13.04. So VB by Vs can be calculated as RI dash divided by RI dash plus RS, where RI dash is 13.04 kilo ohms, okay, divided by kilo or kilo, whereas this one again 13.04 into 10 to the power of 3 plus RS value is 600. So now we need to calculate AVS, where AV, what is the value of AV? We have got 0.997 into 13.04 into 10 to the power of 3 divided by 13.04 into 10 to the power of 3 plus 600. So if you calculate this AVS value, you will be getting this value as 0.953. So this is the AVS value. So here even the overall voltage gain is also almost equal to 1. So that is the calculation of overall voltage gain. Now let us consider the overall current gain. I hope it is clear. So now let us consider the overall current gain. Overall current gain, which is AIS. And here, in order to calculate this one, so first of all, AIS, that is the overall current gain. So IL divided by IS. So what I'm doing here is, I'm multiplying and dividing this one by IE and also IB, input current and output current. I'm multiplying and dividing. And then I'm rearranging the terms. How I'm rearranging the terms? That is, so IL divided by IE into and IB divided by IS into next. So IL divided by IE is gone and IB divided by IS is gone, and the next one is IE divided by IB, where IE divided by IB is nothing but current gain. So I can write it as current gain AI into IL by IE into IB by IS. Now I want to calculate these values. So for that, first what I'm doing, I want to calculate this value. In order to calculate this value, I am considering the Norton's equivalent circuit of input. So let us consider, this is RB, where you all know that RB is equals to R1 in parallel with R2, and this is in parallel with RI. This is in parallel with RI, where the current flowing through this one is IB, and here through this one is IS. So now I want to apply the voltage current divider principle because it is a Norton's equivalent circuit. So here what I'm doing, I just want to calculate IB value. So the current division principle says that the current across a resistance is equals to the input current into the opposite resistance. What is the opposite resistance? RB into RB divided by total resistance. What is the total resistance? RB plus RA. So IB by IS can be written as RB divided by RB plus RA. Okay. And similarly, consider the output equivalent circuit. What is the output equivalent circuit? We have RE in parallel with RL, right? So here the current flowing through this one is IL, and here this is input current is IE. Now from this output equivalent circuit, I can find out IL, which is a current flowing through the resistor RL. So and hence that is given by IE into opposite resistance. What is the opposite resistance to the RL? That is RE divided by RE plus RL. So that means I can find out IL by IE as RE divided by RE plus RL. So now just substitute all these formulas here. So AIS, where we already know calculated the value of AI, that is 76.44 into RB value, we already know it, 13.5K divided by 13.5K plus RI value. What is the value of RI? We have got RI value as 383.2K into RE value is 5. RE value, what is the value of RE? 5.6K and RL is 47K. So RE value is 5.6K divided by 5.6K plus RL value is 47K. If you evaluate all this value, if you calculate all this, then I will be getting the AIS, which is a current gain, the overall current gain. So the overall current gain will be 7.754. So this is the overall current gain. So like that, we can evaluate all the parameters of common collector configuration. So overall current gain and the value of overall current gain is this one. So where IB by IS is RB by RB plus RI, where IL by IE is given by RE by RL, where IE by IB is nothing but AI. So this is the value of overall current gain, and this is how we can analyze all the characteristic parameters of common collector amplifier. So that is how I wanted to discuss all the parameters calculation in a single problem. Now let us take a simple problem. So a bipolar junction transistor with HIE is 1100 ohms, HFE 50, HRE 2.4 into 10 to the power of minus 4, HOE 25 microamperes per volt, right? Is to derive a load of 10 kilo ohms and RS 1 kilo ohm in emitter follower arrangement. Estimate AI, RI, AV and R0. So here in this case, there is no R1, R2, RE is also not there. Only RS is there and RL is there. So, and he didn't ask us to draw the equivalent circuit also. As I wanted to show, I have drawn the equivalent circuit. So, it is just a simple formula substitution. So, again, he has given H parameters of common emitter configuration. So, now again, we need to convert them into common collector configuration. So just remember the formula. HIC is equals to HIE, which is 1100 ohms, or else we can also write it as 1.1 K, and HRC is equals to 1 and HFC is equals to minus of 1 plus HFE, where this value can be minus of 1 plus 50 because HFE value is 50, it is given in this problem. So minus 51. And HOC is equals to HOE, where HOE value is given, which is given by 25 into 10 to the power of minus 6 amperes per volt, right? So these are the conversions. So once it is done, so now what we need to do, we need to calculate all the parameters. What are all the parameters? So first, current gain. So we already know the formula. AI is equals to what? Minus HFC divided by 1 plus HOC into RL. Here no need to take RL dash because here no emitter resistance is given. Even RI dash also no need to calculate it because we have only RS. We don't have any other resistive elements here. So just substitute all the values. Minus HFC is minus of minus 51 divided by 1 plus HOC is 25 into 10 to the power of minus 6 into RL value is, how much is the RL value? That is 10K, 10 into 10 to the power of 3. If you calculate this AI value, you will be getting, always you remember current gain is more when compared to the voltage gain. Voltage gain is unity in case of common collector amplifier. So AI is 41.13. So this is the current gain, right? Next, coming to the voltage gain. So now the voltage gain AV. Okay, so before AV, we are going to calculate RI. So why? Because in order to calculate AV, we need to have input impedance. So input impedance RI is equals to HIC plus HRC into AI into RL. So just substitute the values. 1100, that is HIC value. HRC value is 1 into 41.13 into RL value is, how much is the RL value? RL value is 10 into 10 to the power of 3. So if you calculate this, RI value will be 412.4 kilo ohms. So this is the value of RI. This is the value of RI. So now coming to the next thing, AV. So which is AV. So the formula for AV, that is simple formula, AI into RL by RI. So AI value is 41.13 into RL value. How much is the RL value? 10 into 10 to the power of 3 divided by RI. How much value we have got? 412.4. 412.4 into 10 to the power of 3. So if you calculate this AV, you will be getting this value as 0.997. So this is a value of AV. Overall, voltage gain. Here you didn't ask to find overall voltage gain and overall current gain. So this is the value of overall voltage gain and overall current gain. And similarly, you can also find out the output impedance. So you already know the formula. So the output impedance R0 is equals to 1 by Y0, where 1 by HOC minus HFC into HRC divided by HIC plus RS dash. Actually RS dash we should use, but no other elements are there. We can directly take it as RS. So 1 by HOC is 25 into 10 to the power of minus 6 minus HFC is minus 51 into 1 divided by HIC value is 1100 plus RS value. How much is the RS value given? 1K. 1K means 1000. If you calculate this one, you will be getting some value which will be very less than, that is approximately equals to, I have not calculated this value, approximately equals to some 20 ohms or something. This may not be exact value. So this is the value of R0. So that is about the second problem. And now third one, draw the small signal equivalent circuit of emitter follower using accurate H parameter model. For the emitter follower circuit with RS is equals to 0.5K and RL 5K, calculate AI, RI, AV, R0, assume the values of HFE these are the values given. So as he didn't give R1 and R2, we don't have R1 and R2. It is a simple common collector amplifier. Emitter follower means always you remember it is a common collector configuration. Okay, why? Because the voltage gain is equal to almost equal to 1. It means the output voltage is equals to the input voltage. That is why we are calling it as emitter follower. So don't get confused. If emitter follower is given, you have to realize that it is a common collector configuration. So now we are going to draw the equivalent circuit. So any amplifier will have what? A voltage source in series with a resistance. Okay, voltage source in series with a resistance, and we don't have any other resistances here, R1, R2, nothing is there. So directly we have HIC, and then we have a voltage source plus and minus. This is HIC. And the current flowing through this HIC is IB, because this terminal is base terminal, because it is a common collector configuration. Base is the emitter input terminal, and the voltage is input voltage is VB, and here the magnitude of this one is HRC into VE. HRC into VE, because VE is the output voltage. Okay, VB is the input voltage and VE is the output voltage. And this one is HFC into IB. This is the current source at the output side. We do have HOC, and this terminal is a emitter terminal, and the current flowing through this emitter terminal is IE. And even at the output side, we don't have any RE. So directly it is given RL. So RL is given, and here the current flowing through RL is IL, and the voltage measured across this one is V0, which is equals to VE, because we are measuring the output voltage across the emitter terminal. So that is why it is VE. Okay, so this is the equivalent circuit of emitter follower. Now he asked us to find all the parameters. So before that, first conversion, HIC is HIE, which is 1K, 1 kilo ohm. HRC is equals to 1, and HFC is equals to minus of 1 plus HFE. What's the value of HFE given? That is 50 again. So minus 51. So HFC value is minus 51. HOC is equals to HOE. And what is the value of HOE given? That is 25 microamperes per volt. Right? So these are the values. So simple formula substitution. AI minus HFC divided by 1 plus HOC into RL. No need to calculate any RL dash anything, because we don't have any other elements connected in the output network. So that is why directly we need to take RL, and the voltage, before that we are going to calculate RI. So what is the formula for RI? So RI, you know, that is HIC plus HRC into AI into RL. So here, whatever the value we are getting for RI, just substitute that, and RL value you substitute, so that you can calculate RI. And similarly, AV, so you know the value of formula for AV. So AI into RL by RA. So once after calculating RA, just substitute. And we no need to calculate even RA dash because we don't have any other resistors connected at the input side. And we no need to this is R0. So whereas the output R0 dash can be given by R0 in parallel with R. So now what is the formula for R0? We know that 1 by HOC plus, HOC minus, just a second, HOC minus HFC into HRC divided by HIC plus, actually we used to write RS dash, but we don't have any other element, so simply we need to write RS. Okay, once it is calculated, you can calculate overall output impedance R0 dash, which is calculated as R0 in parallel with RL. So these are all the formulas. Just substitute all the values and you can calculate all these parameters. Okay. So these are the different kinds of problems that may be asked on common collector amplifier exact analysis, that is using hybrid parameter model. So I hope it is clear to you all. That's all for this lecture. So in this lecture, actually we have discussed the problems on common collector amplifier. So for solving any problems either on common base or common collector or common emitter, we need to remember the conversion formulae and the typical values of hybrid parameters and the formulas of all these characteristic parameters in terms of H parameters. So I think it is clear to you all. That's all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.